There seems to be a misunderstanding regarding the James Webb Space Telescope, JWST, capturing the first ever real image of Oumuamua. To date, there have been no publicly confirmed reports or scientific announcements that JWST has directly imaged Oumuamua. Discovered in October 2017 by the Pan-STARRS 1 telescope in Hawaii, Oumuamua was the first known interstellar object to pass through our solar system. Its unusual elongated shape, high speed, and non-gravitational acceleration led to widespread speculation about its nature, with theories ranging from a peculiar asteroid or comet to more exotic ideas like an alien probe. However, the object was moving away from the Sun and Earth by the time it was discovered, making detailed observations challenging. After its discovery, telescopes around the world, including the Hubble Space Telescope, made follow-up observations, but no mission was able to capture detailed images of Oumuamua. Most data collected on it came from spectral analysis and measurements of its brightness, which provided insights into its size, shape, and trajectory but not a detailed visual image. JWST, launched in December 2021, is equipped with advanced infrared capabilities, allowing it to observe distant and faint objects in the universe with unprecedented detail. However, Oumuamua was already far beyond the reach of most telescopes by the time JWST became operational. The telescope's primary mission included studying the early universe, exoplanets, and distant galaxies, and while it has the capability to observe near-Earth objects, focusing on Oumuamua is not within its immediate mission objectives. The fascination with Oumuamua stems from its status as the first identified interstellar visitor, sparking numerous scientific papers and public interest. Its high-speed entry and exit from our solar system suggested originated outside of our solar system, possibly from another star. Theories about its non-cometary nature included the absence of a visible coma, typically associated with comets, and its peculiar acceleration, which couldn't be fully explained by gravitational forces alone. Efforts to understand Oumuamua continue primarily through data analysis and theoretical modeling, with studies exploring possibilities such as hydrogen icebergs, nitrogen ice chunks, or even fragments from a larger interstellar object. Given its fleeting presence in the solar system, opportunities to observe it directly with new telescopes like JWST were never feasible once it moved beyond observational range. Thus, while the James Webb Space Telescope is a groundbreaking tool for exploring the cosmos, as of now, it has not captured any new images of Oumuamua. The legacy of Oumuamua lies in its role as a harbinger of future interstellar discoveries, prompting discussions on how we might observe, study, and perhaps even one day intercept such objects. Scientists are eagerly awaiting the discovery of more interstellar visitors that could provide clearer insights into the materials and conditions present in other parts of our galaxy. Oumuamua's journey through our solar system was brief but groundbreaking, marking the first time an object from outside our solar system was detected passing through. Its name, which means scout or messenger in Hawaiian, reflects the excitement and intrigue it sparked among astronomers and the general public alike. As the first known interstellar visitor, it raised numerous questions about the nature of such objects, their origins, and the broader implications for our understanding of planetary systems beyond our own. When it was first spotted in October 2017, Oumuamua was already on its way out of the solar system, moving at a speed of about 196,000 miles per hour, 315,000 kilometers per hour. Its trajectory indicated that it was not bound by the Sun's gravity, confirming its interstellar origin. Initial observations noted its unusual shape, described as highly elongated, similar to a cigar or a pancake, and its rapid rotation, which was unlike anything seen in local asteroids or comets. The most striking feature of Oumuamua was its unexpected acceleration, which could not be fully explained by gravitational forces alone. Normally, comets exhibit acceleration when they emit gases as they are heated by the Sun, a process known as outgassing. However, Oumuamua did not display any visible signs of outgassing, such as a tail or a coma, which led scientists to consider other possibilities. Some researchers speculated that the object might be composed of materials like hydrogen ice or nitrogen ice, which could sublimate without leaving a detectable trail. Others proposed that it could be a fragment from a larger body, shaped by cosmic collisions or tidal forces. The mystery deepened with a suggestion by some researchers, including Harvard astrophysicist Avi Loeb, that Oumuamua could be an artificial object, possibly a light sail from an alien civilization. While this idea was highly controversial and not widely accepted in the scientific community, it underscored the need for more data on interstellar objects and fueled public fascination. Unfortunately, the brief window for observing Oumuamua made it impossible to gather all the data needed to definitively categorize it. Its rapid exit from the inner solar system meant that by the time the James Webb Space Telescope was operational, Oumuamua was too far away and too dim for any further observation. The JWST, with its unparalleled ability to observe distant objects in infrared light, is focused on studying phenomena such as the formation of stars and planets, the composition of exoplanet atmospheres, and the early universe. While it can observe closer targets, the practical constraints of its mission mean that it has not, and likely will not, image Oumuamua directly. The passage of Oumuamua has nevertheless spurred the astronomical community to prepare for future interstellar visitors. Instruments like the upcoming Vera C. Rubin Observatory, set to begin operations in the next few years, are expected to detect more such objects with greater frequency. This observatory will have a wide field of view and rapid survey capabilities, making it ideal for spotting fast-moving objects that could be interstellar in origin. Further space missions are being conceptualized that could intercept future interstellar objects. These missions would be designed to approach and study these visitors up close, providing data that could reveal their composition, structure, and origins in detail. Such missions could involve rapid response spacecraft capable of launching soon after the detection of a suitable target, equipped with instruments to analyze the object as it passes through the solar system. Oumuamua's journey through our solar system marked a profound moment in the history of astronomy, fundamentally altering our understanding of interstellar objects. Its discovery underscored the reality that our solar system is not an isolated island but part of a broader interstellar community, with objects traveling vast distances between stars. The initial excitement around Oumuamua's discovery quickly turned into a race against time to gather as much information as possible before it slipped beyond the reach of telescopes. In the days following its discovery, observations with some of the world's most powerful telescopes, including the Very Large Telescope in Chile and the Hubble Space Telescope, provided critical insights. Scientists were able to measure Oumuamua's brightness changes, revealing its elongated, tumbling nature. These observations suggested that the object was spinning roughly once every 7.3 hours and that its shape was unlike anything previously observed, possibly 10 times longer than it was wide. This cigar-like or pancake-like shape was unprecedented among known asteroids and comets, adding to the mystery of its origins and composition. One of the biggest puzzles was its unexplained acceleration as it moved away from the Sun. In typical comets, such acceleration is caused by jets of gas and dust released as the comet warms up near the Sun. However, Oumuamua showed no signs of such outgassing, and none of the observed acceleration could be matched to known cometary behavior. Researchers considered the possibility that it could be due to outgassing of hydrogen or water ice that was too faint to detect, or that it was propelled by radiation pressure due to its large surface area and small mass, which would be consistent with a thin, light structure. These unusual characteristics led to a wide range of theories about Oumuamua's nature. Some proposed that it could be a fragment of a larger object that was torn apart by tidal forces near its home star or another massive body. Others suggested it might be an entirely new class of object, something we had never seen before because it had come from a different star system with different conditions. The more exotic theories included the possibility that Oumuamua was an artificial object, perhaps a probe or piece of debris from an alien civilization. This idea, popularized by Avi Loeb and others, captured the public's imagination but was met with skepticism within the scientific community. Most experts favored natural explanations, though the debate highlighted how little we know about the diversity of objects that might exist in the galaxy. Oumuamua's rapid passage through the solar system left scientists with limited data, forcing them to rely on indirect observations and models to piece together its story. The realization that Oumuamua was a visitor from another star system raised significant interest in developing strategies for detecting and studying future interstellar objects. This includes efforts like the Interstellar Probe mission concept, which aims to send a spacecraft beyond the influence of the Sun to observe the interstellar medium directly and potentially intercept objects like Oumuamua in the future. The launch of the James Webb Space Telescope, JWST, was initially seen as a new opportunity to study distant, faint objects with its advanced infrared capabilities. However, by the time JWST became operational, Oumuamua was already too distant and too faint to observe directly. The JWST focuses on some of the most profound questions in cosmology and exoplanet science, such as studying the formation of galaxies in the early universe, observing star and planet formation in nearby galaxies, and characterizing the atmospheres of potentially habitable exoplanets. While it could theoretically observe objects like Oumuamua, its operational priorities and the timing of its launch meant it was not a feasible tool for studying this particular interstellar visitor.